In this talk, Elsa will be presenting a framework to assess the socio-hydrological resilience of cities and look at mitigation strategies for the particular case of Mexico City. So please help me in welcoming Professor Arcaute.
I think the mic is not working. Yeah. Hi. Is it working? Oh, yeah, it's working now. Oh, my God, you made me too much. Right. Okay, thank you very much. So first of all, I have to extend my gratitude for inviting me to come to this beautiful country. It's my first time here, so thank you very much for this invitation. And I'm thrilled this morning. All the talks were absolutely amazing, you know, full of amazing women. So thank you very much for this. So it's going to be a very, very difficult act to follow after all the contributions of this morning. But I'm very happy that, sorry, I think this thing is not working either.
Just need to adjust the microphone. Yes, let it closer to your ears.
Maybe here, yeah?
Let's try.
Okay, let's try.
Can you put it on the other side?
On the other side.
Same direction. Yes. Okay, thank you.
Okay. Right, so can you hear me better now? Let me know when you cannot hear me, you know, just in case. So what I was saying is that I'm very happy that Hiva talked this morning about many things that actually are very related to her talk, and she beautifully defined the main issue of trying to bring multidisciplinary approaches in order to be able to understand any type of problems that we're facing with respect to urban systems. So thank you very much, Hiva, for this. I'm going to take it from there. I hope you were all present at her presentation. So mainly the main points that I want to convey today is to show you, when we're thinking about the problem of water in Mexico City, how you have this really multidimensional approach, which I think this morning you have already, you know, got the hang of it. You need to think about the many different dimensions. But the difficulty when you have all these different dimensions is how do you bring them together? So we saw this morning how you might have one system having one specific type of dynamic going very slow, as opposed to another system being coupled to it and having very fast dynamics. So how do you couple these systems and make sense of those things? So these are open questions that I'm going to be addressing today, but just to keep in mind of the importance when you work in a multidisciplinary approach, how you can do these type of things. And furthermore, when you're working in this type of multidisciplinary approaches, you're co-designing tools in order to be able to take into account the many different perspectives. And that sometimes can be problematic because some stakeholders will think that the aspect, the socio-demographic aspect, for example, has a higher weight than the infrastructural aspect. So bringing all these tools together, so I don't have a solution for this. What we have here is just, I'm going to show you, this is a very short talk, I'm just going to show you more or less the approach that we took. But I want you to keep in mind that this is a challenge that we still haven't been able to sort out. Then the next thing is, when we're talking about all these systems, we have systems that have the data at different granularities. How do you couple the different granularities of this data, and how do you define the extent of your system? So we saw, for example, if we have water systems, those systems will have a different extent to the social one in which we have data about those things. So again, something else to keep in mind. And once you have managed to more or less get a solution, how are you going to prioritize your intervention when you have a finite budget and you cannot, you know, like have an intervention everywhere in your system? And to conclude, I'm going to show you as well, in order to be able to address this type of issues, take it into account stakeholders and people that really understand how these models come together, I'm going to show you the web tool that we did. This is a very short project that we did over 9 months or something like that, so there is a lot of room for improvement, but it's an initiation into trying of proof of concept, how to really bring all these things together. So the problem of water, oh, I see that everything has been redesigned in this I sent my slides and they've been converted into yes. Okay, so it seems that unfortunately the format of the slides in this are not the same, but I hope you can read them. Right, so this is Mexico City before colonization. So you cannot read the dates over there, but this is 14th century Mexico City. So before colonization, Mexico City looked like Venice. It looked like a little Venice with canals everywhere and with a way of agriculture that is very different to the one that we have nowadays. And this is more or less how you can see, how people were living in those areas. So after colonization, this is how Mexico City looks like. You wouldn't see any kind of signal that there was some sort of, like Mexico City being founded on a little islet, so to speak. You wouldn't see that anymore. It will be an extent of land that you wouldn't see that it was really on top of a lake. And furthermore, to kind of imagine that from a system like this one to a system like that one, you have problems of water. Problems of waters that are really, really complicated. And this is how Mexico looks like nowadays, in which you have the main church. So you have the main temple, like the main pyramid that you can see at the bottom over there. And now, of course, that was replaced, with the main church, the main cathedral, in order to impose as well religion and so forth via colonization. So you have the ruins coexisting in that way. So what is going on with respect to the problem of water in Mexico City? So what happened was that they extracted all the water from the subsoils, and nowadays what you have is an issue not only that you don't have enough water and the center of Mexico City is sinking, but also you have a problem of distribution of water, problem of taking care of the infrastructure where all these pipelines are. And of course, the ones suffering the big impact of all this lack of infrastructure, this bad organization with respect to distribution and so forth, are the ones, of course, that are in informal settlements or in the places in the city that are the poorest. And the middle class will have, like they wouldn't even realize there is a problem because you have a tank, on top of your house from which you can get water, even though it is closed from, say, 6 o'clock, you wouldn't have. And then you will still be able to open the tap and have water. So you have pollution, you have management, you have infrastructure, you have all sorts of things coming together in a problem like this one. So in order to solve, a problem like this one, you cannot really, you need you need a big budget in order to put together all these type of things and consider not only the physical dimension of what is going on in your city, but also the socio-demographic dimension. Who are the ones suffering? What is happening when you have these issues going on? And all that, I don't have to motivate it further because thanks to the lovely speakers this morning, you have seen that this is very, very important, right? So you have a relationship, a coexistence of these type of systems coming together. And so in order, apologies for the slides. I didn't check them after I sent them, but I hope you can still see what is going on. So in order to sort this problem, it was very well explained this morning by Hiba, you create one indicator that relates to the social aspect of your system, socio-demographic aspect of your system, and look as well at the vulnerability of this type of things, while at the same time you're going to couple with all these other networks of infrastructure and so forth. And so one way to try to put all this together that has been put forward by other people, Jaramillo and so forth, is to create this index of socio-hydrological resilience. So to put together water stress on the one side, in addition to all the social aspects as well. So you have these two things that each of those have many, many dimensions. And so basically, you want to see how the society is able as well, what is the capacity of the society to adapt to all these problems that they are facing. So this is a map that, of course, you won't be able even to read what is inside of these things, but it more or less tells you about the difficulty that we're facing, right? So on the one hand, so you have social hydrological resilience being composed of two main components. water stress on one side and the adaptive capacity on the other. And you will see how each of these indices, each of these aspects branches out into many different things that come in together, the amount of water that you have, and so forth, on the one hand. So you have many, many different things coming together at the same time as you have many different things coming together, for the adaptive capacity of the system. So in this sense, what I experience, so as I was introduced, I'm a physicist, and most of the time I want to create models that more or less are probabilistic models, but they are framed either because you have a very strong theoretical framework or they are data-driven. In this case, you have these indicators, so you have all these measures of all these different things, and then you invite to the table stakeholders and decide which weight this is going to take, okay? So you put weights according to these discussions of how you're going to construct one indicator that is going to tell you which are more important. So the vulnerability of the system is going to be evaluated, yes, according to the weights that you're going to put, yes? And so in this context, then you can build many different perspectives, the perspective, the social perspective, the physical perspective, and so forth. But you can see the ones that are with me with respect to this idea of models that don't have this amount of uncertainty in it. That is something that we can work in order to try to figure out, Maybe we can put it, I have ideas for this, but we can talk about this later. But these are more for discussion later on if anybody is interested about these things. So overall, what I want to show you is that whatever you're going to observe is the outcome of that. Most of the time, you will see that you have linear models being kind of fit into this type of things. What does it mean? You are thinking, or you leave all the dimensions and you rank them, and it will be the equivalent of having a weight of 1. Yes? Okay. So what is the solution when you have such a complex system in which you don't have a country that can really inject all the money in order to make big changes of infrastructure and so forth? So one of the propositions in order to bring forward to this type of problems is a bottom-up decentralized solution. So how does it work? It's a very small intervention, so it's constructed wetlands that can be done, at your home. So basically, you put this wetland, and it's able to clean the water. You're able also to have to grow some flowers, so you create employments. You have, some way to have income as well from these constructed wetlands. But of course, when you have things like that, you cannot put them everywhere, right? So first of all, you need to educate as well the population where you're going to be putting these things. You need the persons, the inhabitants as well, to accept this new technology. Yes, so it cannot be put wherever you want. And you also need the topography in order to be able to do this. So in order to design then the solution for this type of things, we need to investigate first which are the spaces that have, higher vulnerability with respect to socio-hydrological resilience. Right, so, okay, so we were given this task. This was the project. Let us look at socio-hydrological resilience in Mexico City, yes? So Mexico City, right? If I say Mexico City, everybody will think, oh, it's a city, it's a chaotic city, lots of people, like 20 million people. But when you look at the administrative definition of Mexico City, it only has 9 million people. And it's kind of a random boundary, put in there, while the metropolitan area will have around the 22 million that you're expecting and that you really see. So normally when one thinks about these urban systems, we have the urban core and we think about the metropolitan area as the spaces from which people will commute to these cores to work, right? And you can have, for example, in London, you have a green belt, so you cannot grow beyond this green belt, and your metropolitan area will consist of spaces that you're adding into this area that is contained. Yes? While here you have a seamless expansion. So if you're not going to take the whole metropolitan area, which part of this space you're going to take, you know? So for a minimalistic extension of what you consider Mexico City, how you're going to extend it in order to make sense of the type of intervention that you're doing. So there is no unique way to define a city because it depends on the type of problem that you have, what is that you're measuring. So if you're thinking about GDP or type of innovation, things related to economic activity, you will need to consider metropolitan areas. If you're thinking about more infrastructural things, you want a continuous extent of your environment. Oh my God, this is so bad. I should have checked the slides. They look very nice in my computer, but in here it's all messed up. Right, so how are we going then to extend this idea of Mexico City to something that makes sense, right? So on the one hand, as we say, we want a continuous. We want to see first, when we're going to be thinking about the space, whether the people that are in this space, who are the people that we are missing out with the definition, the minimalistic definition that we had before, Mexico City. So who are we leaving behind? Who need to be included? How are you going to extend this definition to include further people? So you think about the connectivity of your system and the probability of interactions of individuals. If you have an innovation and you want this innovation to diffuse in your system, it will only happen in communities where people know each other. So if my neighbor that I get along with have this, you know, maybe I'm also happy to have this or to help with this. If on the other hand is somebody that I don't relate to this person at all, maybe I'm not going to uptake this type of technology, okay? So in order to do that, what we need to consider then is this probability of interactions between individuals so that we're able to diffuse this technology or we're able to analyze the system as what is going on from one place to another. So in this sense, we're thinking about two things. On the one hand, what is the proximity of the individuals in the space? Yes. And then on the other hand, we're thinking about what is the likelihood for these individuals to interact? So in order to think about proximity, you have to take the transport network, right? So here we simplify the transport network into the road network, you know, because there is a limitation of the underground area in Mexico, and also because the bus system, it's a bit of a mess. I'm not going to go into details right now. Then if you think about the socio-demographic one, you need to think about this proximity with respect to the homophily principle. The likelihood, I'm going to interact with people that are similar to me. So when we consider the distance in terms of the infrastructure, which distance are you going to choose, right? What is a good distance? And somebody will say, oh, maybe 200 meters because that's how, you know, the urbanized space is defined in France, for example. But there isn't really like a threshold in which you can say this is a good measurement, yes? So what we're doing is that we are looking at all the space and we're trying to see whether one distance, you know, there is a transition in terms of what the interactions could be in order to define this distance, okay? So I can see that there is a lot of continuity here and then all of a sudden there is nothing and then all of a sudden there is more, yes? Things like that. So if you do this, let's see if this works. It works, it seems. Okay, so if we do this, this is more or less what you have. So imagine that there was a message or there was, you know, some sort of disease spreading in the space. So what you're going to see is this is the road network in Mexico. Well, I don't know whether you're going to see anything. Maybe if you switch off the lights, people are going to be able to see, please. Okay, thank you. So you have here the road network, the points of intersections, and what you're going to see, it is as if there was a disease spreading in the space, okay? So you're going to see different colors. The red one is the largest cluster, while the other ones are smaller clusters. Okay, almost there, okay. It doesn't work. You're not going to see anything. That's why I wanted to present with my computer. No, it doesn't work. Okay, never mind. I have my computer over there, but doesn't matter. Okay, so in principle, what you see is how, when you have the city, how you will have different clusters according to connectivity presenting. Then we move on into the next step. Okay, so maybe this is how a disease would spread if I was talking with everyone that I was going to encounter. But what if instead I'm considering how to create communities, taking into account the probability of them to interact according to the homophily principle. So as I said, you're going to interact with people that are more similar to you. So how are you going to do this? If you would have some sort of data set, say, like phone calls between individuals, you will be able to do this. But most of the time, we don't have this. So the proxy that we're going to create is you have your space. This space has socio-demographic characteristics, and you're going to say people are going to interact if the similarity between them is high. So basically, you have your areas where you have your data, and then the link with your nearest neighbor is going to give you how similar they are. So this is an advertisement. Come tomorrow to my talk, and I'll explain how to create these things. So what you end up doing is the same. So which level of similarity are you going to take in order to say this is good enough for people to interact? Still, you don't know, okay? You don't know, and so we're going to look at all the parameter space and see more or less whether you have this type of transitions again. And what happens is the following. So you have maps that are at the top that relate to how people will be linking according to the infrastructure, the transport infrastructure that is in there. And then below, you have how people will be interacting according to the similarity, okay? And so what is it that you observe? You observe that the red one is the largest cluster that you have in your system. And what you can see is that as you go through these spaces, the ones that are in circles are the ones that are not included in the initial definition, but nevertheless are very connected to what you defined as the Mexico City, yes? So all the ones in circles were the ones that were being left behind if you didn't extend your definition, okay? So when we observe this and we're trying to extend the definition, we decide then to include these clusters, okay? So if we pause for a bit and we say, okay, so which were the clusters that I was leaving behind? This is one of them. So ciudad means city, right? So one of the places that we were leaving behind in Mexico City had 1 million people living inside, okay? Just to give you an idea of the scale of the issue. And then when you look at the picture of the place that you were leaving behind, does it look like a wealthy place where people are doing very well? It doesn't, right? So it looks really a place that will need a lot of intervention in addition to being very connected to the space in both, in the infrastructural and also in the socio-demographic context, okay? So just to bear in mind that any kind of analysis and intervention that we're going to make is going to have biases and is going to have limitations, and just to be aware which are the limitations and who we're leaving behind, it's an important fact. So this is an example of the tool. You can go there in order to test it, yes, to look around and see what is going on. And then what you can see is that for one way to look at the system, according to one of the perspectives, you will be able to color the space, as you have seen in the previous talks, like this type of web tools, in order to identify the places that are in need of this intervention. And as you can see, the places that we're leaving behind are places that were most in need of the intervention. But then you don't have enough money in order to cover all the areas that you would like to cover. So the parenthesis here is that if you go in there, then you will see the different colors appearing according to other perspectives, prioritizing social aspects or stakeholders aspect or so forth, yes? So how then you're going to put an intervention if you don't have an infinite amount of money to do this. So the way that you're going to do this is to assess the vulnerability on the one hand, and then on the other hand, to assess the viability of the project to be put into this space, yes, and optimize, the budget according to that. So, given that I have 30 seconds left according to I'm going to rush. So how do you do this? You evaluate, like this idea of viability in addition to the vulnerability, okay? So viability according to all these other things. And if you have budget that is not infinite, then with this tool you can see, according to amount of budget, where you should prioritize these spaces. And in addition, what sort of what is it, which benefits you're going to get. So then when you come with your stakeholders in order to present a sort of intervention, there is a bit of information of how to move forward. And so this is if the budget was higher. Right, so to conclude, I'm going to show tomorrow the difficulty in order to define communities and the different ways to do this type of things. So there is no unique way to do this. One of the questions could be, Elsa, you're taking on the one hand the distance between individuals, and then on the other, you're taking the similarity between them. Why do you take them separately? Why don't you join them? Yes, we can join them. Tomorrow I'll show you one way of doing this type of things. And most crucially, I didn't talk about this, but of course, in a system like this one, you have missing data. So what do you do in a system when you have missing data? So most of the time, what people will do is that they will have data around, and they will take the one in the middle where they're missing data and take the average. And of course, if the data is missing, it means because it must be below the average of all the surrounding data, right? So these are I'm bringing you more problems and solutions of how to do these things. And the last thing is one of the things that I wanted to ask you, Hiba, as well, with respect to how you do these things. So on the one hand, you have the data that you have, when you're thinking about all these different systems that you're coupling, the granularity of the data, the geographical scale is different. So how do you manage to bring about and harmonize all these different scales and so forth? So in order to do this, we need a transdisciplinary group that understands what is being left behind, what are the biases, and what are the limitations. And this is my final slide of the amazing people, as you can see, very transdisciplinary group of people with whom I closely work for this project. Thank you very much.
Thank you, Elsa. I hate to be the very strict moderator. I'm just going to allow one question, and you get the chance to talk to Elsa extensively tomorrow. But very short question, and with a very short response, so that we move to our remotely joining speaker. Please.
Thank you for the presentation. I actually have two questions, if that's okay. They may not be necessarily on Mexico, but...
It's just one, please.
Okay. With the emergence of the topic of smart cities, there is talk about being very restricted in where you're allowed to go without governmental permission, like maybe not being able to drive on highways without permission, or being very limited in the proximity that you can go. I don't know if you've heard of this yet, like smart cities basically being debunked, and if you have any opinion on that.
About smart cities.
Yes.
So you're changing subjects with completely in that respect. So I think we need to talk about, like all the issues with respect to smart cities, because I think one of the main things when you bring about any kind of system with respect to smart cities is this idea of who you're leaving behind. So you bring in a digital twin in order to be able to analyze your system, so you will have different models that need to be coupled again about different projections of the populations and things like that. But of course, in your models, you're leaving people behind in this type of data sets. Who is going to be able to use this data? Who is not going to be able to use this data? And so, how do you do you take into account all these things in order to propose something for a smart cities project? Yes. Apologies that I didn't know I was going to be put in the smart cities thing, otherwise I would have chosen something different.
It's fine. So tomorrow, just another advertisement.
No, but I won't be talking about
yeah, I know,
smart cities.
but you can ask her more detailed question because it's going to be a more comfortable setting. And hopefully won't be running bad on time. So now please help me in thanking Professor Arcaute.